Assalamu alaikum. This is Dr. Usman Sadiq Paracha, and we would be having our lecture number 12 of the subject Applied Quantitative Practices. And in this case, let's have a look at the previous lecture which we had. And in this previous lecture, we had a brief exercise on how to go through coefficient of correlation in SPSS. How can we find this coefficient in this software, and what are the implications of this software, because it's easy to just find out the correlation coefficient R there, but sometimes, like we discussed, that instead of two variables, a third variable can also have an impact on the relationship between the two variables we have already analyzed. So in order to remove the impact of that third variable, we just discussed that how to control it, and in that way how to basically use the option of partial correlation in this case. Once we went through the partial correlation, we had to basically mention that which variable should be controlled and how it should be controlled. So then we discussed about how the result is displayed and how it can be interpreted. So basically sometimes it's the relationship analysis is not that easy, and quite a number of variables are basically impacting the very simple relationship, which seems very simple, but then the impact of an intervening variable makes it quite complicated. So we just went through this procedure of how to find out this coefficient, and then we went to the partial correlation fact in SPSS, and after that how we interpret it was the part we covered. Now, after partial correlation, we had a discussion about the ethical considerations, because we have to be very objective in our data, and there are very few basically options in which we can have some subjective conclusions. So the more objective our approach is towards our data, the more unbiased our study will be. So we had to ensure that we do basically cover these ethical considerations, which are now specifically important in nowadays research. So in that case, we had a brief discussion on this, and then we went on to the normal distribution phenomena. In normal distribution phenomena, we had just a brief discussion about what is normal distribution, and in that case the important thing is that one of the most important condition for the analysis of data is that the data which is being studied of any variable should be normally distributed. Now here normal distribution means that it should form a bell curve. So the bell curve basically, as we discussed previously, represents this so-called normal distribution, and here basically what we do is that normally it's not possible that every data set is normally distributed. The values do differ, and obviously it's not possible to get an exact bell curve in that case. So in order to go and reach to that curve, what we do is that we convert all the data set of the variable being considered into z values, and we discussed before how to convert the original values of data set into z values. And as we know, z values basically then take the mean of the data set as 0, and then based on standard deviation we plot the whole curve. Once this whole curve is plotted and we have got the z values, then we have the option of finding out the probability. Just having a recap of that, we just had discussed the general procedure of how to find this probability. Now the probability part basically comes into view when specifically we are of the view that as we are taking a sample from the population, then what is the probability that, let's say, when we are saying that mean of that sample is, let's say, 6.8. So how much probability is there that no matter how many samples we take out from that population, the same mean is obtained? So now it's not possible for us to extract innumerable samples from that population. We can only draw one or two, or not more than a few. So then that means that we need some kind of assurance or some kind of measure to tell us that how much probable is the fact that the mean or all the measures which we are calculating would be the same if we are trying to calculate these measures like mean or standard deviation or variance in other samples from the same population. So in order to get that thing, we had to basically find out the probability of the fact that how much probability is there that the same mean figure will be repeated when we are drawing different samples from the same population. Now, in order to do that, the effective way was that we basically convert all the data set values into z values and we plot this curve. Now the main reason behind plotting this curve was that once you plot this curve and we identify that which value probability we want to ascertain, then we can just find out the probability of that value occurrence by simply finding out the area under that specific curve. So in order to go ahead with that, we just followed the general procedure for finding out these normal probabilities, as they are called. And here we have assumed that as the data set is distributed normally, we basically draw the normal curve for the problem in terms of the data set, and then we convert all the data set values into z values, and then we use the standardized normal table which is there at the end of every statistics book available. So from there we can ascertain the z values, and for just an example, we went through a simple example in which you can see a simple curve as shown here. And here this is quite much evident that the whole data set is there, though in this problem we are not given any data set, but we are only specified the mean of that data set, which is 18.0 second, and then we are also given the standard deviation here. Now once we are given these two main figures, then we are asked whether how much probability is there that x, whatever the values, would lie behind this 18.6 value which is there. So what we have done is that, as per standard practice, when we convert these values into basically z values, then the mean of that specific data set is always plotted at the center. As you can see from here, that we have plotted the mean at the center here. Once we have plotted that, then the rest of the values, whether negative and positive, are then plotted alongside. Now here we are given a certain value and we are being asked whether this specific value, how much probability is there that the values of x would be less than these values. So again, in order to find out the probability, then under the law, what we have to do is just to find out the area under this whole curve which you are seeing here. So here in this curve, in order to find out the area, we have got certain established methods, and in that we used a table which we displayed previously. So here again, as it is demonstrated here, we have just converted this table into this curve into another curve in which the values which are standardized have been used. And again, once we know very well that in a standardized curve, the standard deviation here is 1, and then likewise the mu, or the mean, here is 0. So based on that, we have plotted the other values, and then in order to convert the question then rises that how much values lie behind this z value of 0.12. So once we have interpreted this whole original data set into the value of z, which you can see from here, then it's easy to find out the rest of the values. And we just used the normal probability table, and we came to know that there is basically 54.7% probability that the values lying, all the values lying behind 0.12 would be this much, covering this much area. So basically, we have just find out the probability of this, that how much is this, that z would be less than 0.12. So going ahead with that, again, we just went through the opposite task, that how much probability is there that x would be greater than 18.6. So here we just plotted the opposite basically curve under the value. So going through the same procedure, we basically just found out the values by going through the other way around, by first finding out the overall probability as evident from here, and then subtracting it from the known quantity. These methods, again, as it is shown here, this is second example in which we have to find out the probability of occurrence of x in between 18 and 18.6. So all what we did was that we converted again all of these values into z, and then we just basically went through the process of finding these values under the normal probability table, and then we just find out the probability from that method. So this is very much important in real-time phenomena, that when specifically we are asked whether what is the probability that this correlation which we have reported would be reporting the same value again and again if we draw the samples from the population, then we are going through the p-value through the same process. We would go through it in detail in a short while. So this is just the same exercise which we did in another example, in which we had to find the value or occurrence of x in between the values of 17.4 and 18. So again, we are going through the same procedure which we had discussed before, and in that case we just basically try to find out the values other than, because it's not that much easy to basically find out this covered area directly as it is shown here. So what we do is we will just try to find out the area of this basically distance, and once we find out the probability of this, then we can subtract it from the other relevant probabilities which are known, and then we can find out this specific value. So now basically these exercises are just for the fact so that you can easily understand that what's the phenomena of probability. And again, this probability is also shown in our various statistical test results in the form of p, and we have said that p-value should not be greater than 0.05. Now here the concept of p05 basically comes with explanation of certain rules. Now here as we studied the empirical rule before, and here now this same rule is being depicted, that 78.26% of all the values of the data set would be within the first standard deviation, as it is shown here in this specific distance. So basically, again, the same empirical rule gives us some other notions, and here as we can see that 95.4 values should come in between two standard deviations area, and then 99.73% should come within this 3 standard deviations area. So basically now the complication is that you must have seen in our previous test results that the SPSS also reports first the correlation coefficient, for example, at r is equal to 0.028, for example, and then it says that the p-value is 0.002. Now here, what's the p-value and what's its significance? We also say that the significance of this r value which is being reported is 0.02. Now the meaning for that is that we basically first plot all the data set on this curve which you are seeing here, and then as a rule we just find out the probability of the correlation coefficient here, the value, whether the value would lie in between this curve. Now here at the end points you can see that here we draw 2 lines, one here and one here, and basically what we are saying here is that for z value equivalent to 0.25 here and 0.25 here, we have got basically 2 limits of z values. Now within this limit basically lies our acceptance area, and by acceptance area we mean that whenever within the test results it is stated that p-value is less than or in other words p-value is equal to 0.002. That means that the probability of that figure is that there's round about 0.02% probability, and in this case we can say that on the other way around, like there is more than 98% probability that the correlation value which is being reported would be the same if the same result is extracted from another sample drawn from the population. Now here basically how we draw this probability is an important aspect, because when we draw this curve we basically ascertain that how much is the 0.25% value of z lying. So here basically when we are trying to clip off these 0.25% values, in other words if we add them up then 0.25 and 0.25 makes 0.5. So basically we try to ascertain that how much probability is there that the value would lie in between these two limits. Now if we add the limits here 0.25 and 0.25, then it becomes equivalent to 0.5, or we can also write it as 0.05 if we remove the percentage sign. So then the probability aspect is like how much confident we are that the values calculated from SPSS lie in between this region. So here in this case then we are sure that 95% basically limit is there, that at least you should report 95% probability of any value extracted from any SPSS test. So going through that, let's go to the SPSS software, and we can see the initial basically SPSS file which we discussed. And here let's say if I just want to find out the correlation between any two variables here, for example training variable 1 and training variable 2, and I just want to click on OK. So here once the value is reported, like here you can see the training and training variable 1 and training variable 2 correlation is 0.81 here. Now again at the bottom it is written that correlation is significant at the 0.01 level. Now here by this it means that the probability of this value of 0.813 occurring same and the same value is reported again if we draw any other sample from the population. So probability of that value occurring again is more than 99%, because the probability is opposite to the level which is reported here, and the level which is reported here is 0.01. So opposite to that is 0.99. So 99% basically probability is being reported, and thus we say that this value is significant. And by significant we mean that the same value would be repeated again if there's 99% chance of the same value repeated again if the sample basically is extracted and if other samples are extracted from the same population. So this kind of statement and this kind of probability is calculated for every test which we will study in the future also. Now regarding this statement which is called two-tailed, by two-tailed we mean that if we go to this main work, so if we are trying to calculate the probability in between these two edges which you are seeing, with in other words in between this 0.25 and 0.25, then this probability reported is two-tailed, because we are considering both the tails in this case. And in this case, in other words, we are stating that we are not giving any direction of the relationship between training variable 1 and training variable 2. For example, we can say that any kind of relationship can exist, but if we are saying that there is a positive relationship between training variable 1 and training variable 2, then in that case we are giving direction to this test, and that direction is in positive side. So once we are giving a direction, then here we would be testing the probability limit in the one side also. And as we are ensuring 0.5% of confidence here, so then in that case we would be taking another limit which would be at 0.5%. Now here at 0.5 level, which is the z level, then we would be trying to find out the probability in rest of the curve, which is behind this 0.5%, and what is the probability that the value would lie in between from 0 to in fact from 1 and tail end limit to 0.5. But this kind of condition would only exist if we are basically giving the direction to our statement there. So in order to go there back to SPSS, you can see that once we are going to the analyze part, and once we want to find out the correlation in between the two variables, we are asked for the test of significance, whether we want to go for one-tailed or we want to go for two-tailed here. So we can go for the option, let's say here, now we want to go for one-tailed test. So we click on OK, and here now we are being given the figure for one-tailed. So basically it depends upon the nature of variable where the correlation coefficient may be reported different in this case, but normally two-tailed test is used to calculate any test value. So basically this is the explanation, a brief explanation of what is the practical application of that probability phenomena. So this probability factor basically is of extreme importance, because as we don't have the mean of the main population known, because we are unable to get the data from the whole population, specifically in business research field, then we have to take the sample. Now once we are dealing with the sample, then we are not sure whether all the values of any kind of test, whether it's regression, whether it's correlation, whether it's mean, we are not sure that any value calculated from that sample would be the same if another sample is extracted from the same population. So in order to be certain, we then have to calculate probability of the occurrence of these values for these different tests. So in order to basically go through that, then we have to basically follow this standardization of all the values, and then we have to draw the curve to find out the probability of occurrence of any kind of test statistic which we are dealing with. So that's why the whole new chapter of probability or normal distribution or sampling distribution is included in nearly every business statistic book. So going ahead with that, again we just went through that if we are given the probability of known basically sample, then how to find out the original value. So we would just put the whole process in opposite, and the formula would be the opposite as it is shown in the screen here. So we just take an example in which we are given an example regarding an X which represents certain time to download an image. Now here the mean is given and the standard deviation is also provided, and we have to find out that value X such that 20% of download times are less than X. Now here we are given the probability, as you can see here through this region basically, which shows us the probability of occurrence of the specific value, but we are not given the value here which we have to find out. So basically in order to find that out, what we do is we just go through the same procedure but in opposite direction, and we just go to the standard normal probability table and we find out the value which is reported under this specific probability. So all what we have to do is to locate this approximate probability which would be in which would be reported in the tables. Once we have identified the probability value here as shown, then we can just sidetrack it to what's the value being reported on the vertical side and horizontal side both, and by adding these two we can just easily track the probability of that specific value, the original value here. So this is just a procedure which is followed if we want to find out the original value if the probability of that specific value is known. Then going ahead with that, what's the implication? Because how would we be able to evaluate the normality? Because now it is very much clear that we cannot go ahead with any kind of analysis if the data is not normal. So then again we have to find out and evaluate whether the data set which we are seeing is normal or not. So basically this is just a simple statement that how we can approximate the normal distribution, and we know that it should be bell-shaped, and the mean ideally should be equal to median, though it's always not possible. And then again the interquartile range should be equivalent to 1.33 standard deviations. Now these are the conditions which should be there. That's why in order to perform every statistical test, this is a by default rule that the data should be normal. The data set should be normal and it should follow the normal distribution. So then again, how to find out and evaluate this normality? We can construct the graphs and charts as we have done before. We have drawn the box plotting, we have done and made the histograms in SPSS. So basic purpose of drawing these histograms and frequency distribution charts and all those factors is that we want to ensure that the data is normal. Normally, this thing has now been made easy, because now, as a general rule in statistics, if your sample size is greater than 30, then under that certain theorem, which is also called central limit theorem, the distribution of that specific data set would be normal. But this should be kept in mind that in order for that data set to be normal under the central limit theorem, the total number of respondents, or I would say the responses or the data set values, should be greater than 30. In case the values or the data set values are less than 30, then we cannot apply the central limit theorem. So under that, we can assume that the data set would be normal, but it's very important that we try to find out the normality and check the normality of that data set. So again, these are various steps in which we have to compute the various descriptive measures, and we have to find out whether the mean, mode, and median are similar, and then the other condition that the interquartile range should be approximately 1.33, and then a range is approximately 6 times that of the standard deviation. So again, going through that, then again we have to follow the further steps, whether 2/3 of the distributions or the observations lie within the mean first standard deviation. As we have seen that in the normal distribution, the standard formula or the standard rule is that 68% of the values should be in between the first standard deviation area. So we would have to ensure that such rule is applicable here and is evident here. Then again, it should be clear that 80% of the values should lie within 1.28 standard deviation, and then the 95% of the observations should lie between the 2 standard deviation. And these rules are of importance, because if these rules are violated, then again we cannot ensure normal distribution. And once we are not ensuring normal distribution, then the results reported by any type of analysis carried out on the data can be biased and can be with error, with significant error. So also this should be kept in mind that we would have to calculate this normal probability plotting, and this is basically one rule that and this is one tool which gives us a brief idea of the normality of the data which we are studying. So in order to do that, we have to follow certain rules, and we have to ensure that this normal probability plot is linear and is in the form of straight line with a positive slope. So in order to calculate this thing, we have to follow certain procedure, like we have to arrange the data into ordered array. We have discussed ordered array in detail and how to display the data in that ordered array pattern. So once you do that, you then just find out the z values, which are normal quantile values. But again, it should be kept in mind that these are not those typical z values which we have discussed before. These are called quantile values, and these are calculated through a different formula which can be easily found out in all the statistical literature. So once we have find out this standardized normal quantile values, then we can plot these points in which we just take the observed original data values on x-axis and then on the vertical side, and then we take the standardized normal quantile values z on the horizontal axis. Now then, once we have plotted that and we have plotted these points, then we can evaluate the plot for evidence of linearity. So here let's go to SPSS and let's have a look on how this normal probability plotting can be obtained. So let's say we just want to find out the normality aspect of these various variables which are enlisted here. So I just click on Analyze and go to Descriptives, and I click on Explore here. And let's say I just enter the training variable 1 and let's say I just want to find out in the normal probability plotting. I go in Plots, and here you can see that there is another additional option available, and you can click on normality plots with tests, and in that case you can see that under this option the normality plots would be displayed for that individual variable. So let's say you want to see the histogram as well. So we click on Continue, and let's say for now we are only interested in plots. So we just click on Plots here, and we are not that much interested in statistics. So we click on OK, and here we can see the histogram being displayed and the stem and leaf diagram. And here we are given the normal QQ plotting here, which is displayed. Now here this is important that all these values which are shown in the form of dots should lie on the straight line. And if the farther the values, these dots are from that straight line, then again the normality of that data set is then not ensured. So this is very much vital that these values or these data values should be near this line which is being drawn here. So basically this is how we draw the normal plotting here, and then we are being displayed with the box plot which is displayed here, which seems to be normal. So let's go ahead with another variable. We can find out as the values of as many variables as we like. So clicking on Explore, and let's take a different variable now, and we can say that for experience, let's say, and we take back the training variable into the set of variables here, and we try to find out the plot. So we click on Plots, and already normality plots with test is enlisted here, and we can click on histogram as well. So we click on Continue, and we click on OK. So here again we can see, now here is a kind of a different picture, because you can see here that at the bottom side there are a few values which are going far from the line. Now that means that from that end the normality is not that much ensured, but for the majority of the data values, these values are plotted on that straight line. So for majority of the values the normality is being ensured. Then again at the farther end there is one value which is going farther from the line, and again is a sign that from that end the normality may not be ensured. So this also gives us a brief aspect of this value can be the outlier as well. So by double clicking on it, we just open the editing part, and we can basically click on this value, which is the original one, and we right click on it, and we can ask for the SPSS to show data labels. So once we click on that, the data label for that specific point is displayed, and you can see the case number of that value is being displayed here, which is 492. So we can just go to that value and we can try to find out that what's wrong with that specific outlier. So the case number here is displayed, and from here we can track further details of that abnormal value. Likewise, we can just double click on that end value as well, and we can just right click on it and we can ask for the show data labels if we click on this, and we would be given the detail of that case number as well here. So here basically such kind of value is being reported by 4 different cases. So we can check all of these out and try to find out the further details that what's wrong with this phenomena. And so this was just an illustration of how to plot different normal QQ plotting, and the same value can be found out through other options as well. If we go to Analyze and go to Descriptive Statistics, and I guess we can just click on Descriptives, and let's see if we are given the option. No, I think in descriptive options it's not stated here. So we would have to just go to Analyze and go for basically frequencies, and here we can find out the normal QQ plotting by clicking on the charts, but here again we can only go for histogram. So anyhow, this basic facility is available under the Descriptive Statistics in Explore option as well, but we can try to find out these plots individually by going for these PP plots or QQ plots, and because these are also termed as that, and here as this linearity is basically the normal QQ plotting, so we can just get it displayed by clicking on that option individually as well. So now going back to the fact here, you can see that we just found out the normal procedure. So let's go to the example here. This is how a normal probability plot looks like, and we have already gone through that in SPSS window, and we can see that this basically in this example the normal probability plotting is kind of linear here, and then there are other examples like how in certain situations, for example, you can see that in here in this example, if the curve is basically tilted a bit, then this normal probability plot is said to be left skewed. However, in case that same plot is drawn in such case, then in this case we term such a normal probability plot as right skewed. Likewise, if we have to term that certain normality plot as rectangular, then such a shape should be evident here. So basically these are various different shapes, and the interpretation is done according to the shapes of normal probability plotting, which can be done in order to facilitate the viewer in this case. Now here in this case we have just taken an example of a certain data set, and the box plot is basically being showed here, and as we can see that the box plot is skewed to the right, and however the normal distribution is there. So basically this box plot gives us some initial information, but going through the further details we are given the explanation of the mean here, which is being showed here, and the interquartile range, which is shown here as well, and again we are given details of the range which is shown here, and how the observations are basically normally distributed, as we can see that 86%, more than 86% observations are within 1.28 standard deviation. So basically these details gives us a fair picture of the nature of data set. And going to this fact, then again, however, if we draw the normal probability plot, in which here we have used Excel to draw it, we have already discussed how to draw this plot in SPSS. But you can see the values shown here are quite abnormal, though most of the data here at the center is showing linearity. So the exception is with at the top 3 values and at the bottom 2 values shown here. So this normal probability plotting at the extreme end needs to be seen, and these values should be observed and evaluated, because these are probably outliers which are causing such a disturbance in the normal probability plotting. So again, if we go through this same plot, which is being evident from another software called Minitab, because you can use multiple softwares. Here basically what common software being used is SPSS, so we are basically using the analysis technique in SPSS here. So here again we can see the 3 values, the same 3 values which are evident, and then again here at the bottom, and again as this main plot is bending on the top, so it's skewed to the right here. So this is the interpretation which can be given for explanation of such normal probability plotting. So this tool is commonly used to find out the normality factor, because as we have discussed before, that it's now very important for the testing part, for analyzing part, that every variable which is being entered in the model should be basically having a linear pattern, should have linear or normal properties, because only after that we can calculate the probability of various test statistics calculated from that sample. So again, the conclusions of the data set which we just discussed here, the returns overall are rightly skewed, and the values again, they are more concentrated around the mean, and the range is larger than expected. And again, normal probability plot is not a straight line because of the presence of extreme and outliers. So we have to treat those outliers, and that treatment can be basically seen. Now this data set differs from the theoretical properties of the normal distribution, and again overall we can say that we have to reassess the normality assumption of such kind of data set, and this is vital that such kind of data set is observed in detail in order to treatment for the end values. Again, this is the normal distribution, which is the idealized shape which we are discussing about, and basically this is the very reason that this whole debate of finding the probability of the end values is taken in this case. So this is quite vital that the normality of the data set of all individual variables is found out. So in today's lecture, we basically tried to find out how to evaluate the normal probabilities what is the implication of finding these normal probabilities? Because the main issue is that when we are reported a specific p-value in SPSS, then what's the meaning of that p-value and why we need to find out these normal probabilities. And we basically have discussed that the need for that is that the probability calculation is essential when we are drawing a sample from the population. Then how much probability is there that the same in values like mean, mode, or standard deviation, or even correlation, or all the regression coefficients would remain the same if the different sample is taken from the population, and would the same results will be reported. So in order to calculate that, we need to find out the probability of the occurrence of such values. And in order to do that, we have to ensure that the data set is normal. And in that case, we have to then plot all these values into z factor. We have to find out the z values, and then we have to draw the curve, because under that curve, once the values are plotted, we can easily find out the probability by trying to find out the probability or the area under that specific curve. So once the area under that specific curve is calculated, then we can find out the probability. Though it's a complicated procedure, but then it's made easy with the help of the normal distribution table, probability tables, which are provided at the end of every statistics book. So going through that, we just discussed about the importance of these various normal probability phenomena, and then we again discussed the empirical rule implication. What is the actual application of empirical rule, and how we try to assess that when we are stating that we are conducting a two-tailed test or one-tailed test, and what is its interpretation. So how we are trying to find out the probability of z values at two ends of the tail, with amounting to the 95% probability factor. If we want to find out that about the fact that there should be 95% probability of assessing any kind of value, or in other words, this is also stated in the form that the significance level should be less than 0.05. So in other words, we just take the opposite of significance level, and we say that there is 95% probability of the occurrence of that specific value which is being reported in SPSS or manually. So this empirical rule application is very much vital there. Then we try to find out how we evaluate the normality in SPSS, and that is done in the form of normal probability plotting. And in normal probability plotting, we just try to assess that through an example in SPSS, and how that plotting can be assessed through various tools. Once we went through that, we just had an example of a mutual fund, and we just plotted those data set in Excel and Minitab, though we just discussed the results there, but how certain patterns of normal QQ plotting can be shown in the software, and how we can term them as rightly skewed or left skewed, or in any other kind of direction like rectangular skewed. So basically there are different shapes, and every shape has its own interpretation, and we just discussed the abnormalities which can happen at the end of the data or at the tail ends of the data set, as we saw in those examples. So this was the application in SPSS we went through in order to assess how this factor can be analyzed while assessing the normality of a certain data set. So this was the end of this lecture, I hope that you have understood the concepts presented here. Thank you so much. Allah Hafiz.